Hello, everyone, and a warm welcome back to all the participants joining me on this session. Welcome back to all of you people. So, participants, what is our agenda for today? The agenda for today is purely about databases into the cloud. So, participants, what we will go ahead and explore today is the databases into the AWS cloud, because we have already seen the various ways of building pipelines from scratch involving open source tools and involving AWS services. Now, let's go ahead and focus on the databases where data gets stored. So, participants, if you ask me what kind of databases, then you should be aware that databases currently are available, which are
SQL.
SQL compliant, correct? Yes. And
Cosmos DB.
SQL compliant databases. SQL and NoSQL databases. So these are the major databases category that you will get to see. So we also have the same category offerings in AWS Cloud, where SQL databases are available and NoSQL databases are available. What are those? How will? It's the time for us to explore, and that's the agenda for today's session. So participants, let's focus on first thing, a SQL database. So I'm looking for a SQL databases. The moment I type in SQL, I'm ending up on RDS. So participants, what does this RDS stand for? Relational Database as Service, which is a managed relational database service. The way it is branded is it's a managed service offered by AWS Cloud, where you'll get to see the SQL databases given as a service to you. In the same way, if you go ahead and look for NoSQL databases, you'll get to see DynamoDB, which is managed NoSQL databases for you. Everyone, are we clear? Participants, are we clear?
Yes, come on.
Any questions here?
No.
Okay. Now, let's go ahead and start provisioning the databases into the cloud and start connecting to these databases. So first database that I'll go ahead and use is relational database. So participants, keep in mind the cost of the databases are very heavy. So you have to be very careful while you're practicing it. Now what I'm going to do is I'm going to go ahead and start provisioning the database, and please remember the databases are what do you call it as region specific, and very happy to address participants. Hope you are also aware of it, that AWS has started its another region in India. I think this service
That's in Hyderabad.
Yeah, in Hyderabad, I guess they have launched it. Let me go ahead and confirm it. They have launched in Hyderabad. They have launched their data center in Hyderabad. So it's very much that it was in Mumbai initially. Now they have the offerings in Hyderabad also. They have their data centers in Hyderabad region also, 3 data centers. So that's good. A lot of companies are having their, a lot of clients are currently from Hyderabad, they are supporting. So it's just out of the box, nothing to do with the discussion here. So let's go back to RDS. Now, what I'm going to do is, participants, I'm going to go ahead and start provisioning the database instance. Right now, I don't have any RDS database instance. So let me hit create a database. So it will ask you a lot of configurations from your end. So participants, let's go ahead and input those configuration details here. So we are on a create database. Choose a database creation method, standard create. Yes, I would agree to go with standard create. And it does give a lot of options under the engine involving Aurora, which is the product from Amazon itself, MySQL, Postgres, which are open source databases. Oracle and Microsoft SQL servers also provide their databases, but these databases are commercial databases. So for the purpose of practice, let's keep it open, MySQL. So you don't get charged for the MySQL database. It's an open source database. Community edition. So after that, it will ask you to go ahead and choose the engine version. Let's keep it as 8.0 version. And templates. You have various templates. So templates basically is defining what kind of template that you want to use. For what purpose are you using this database? This is just for a purpose of practice that you want to go ahead and use it. If you go ahead and use production, that means there will be a database plus an additional database, highly available server, HMO database will be available, which is not the case that we are looking at. Dev and test, it's up to you. It will be provisioned for you without any high available server. Free tier is just the database that will be provisioned for. So no costs for you. It's under your free tier limits, you will be able to use it. So I'll use this free tier database. Next, it will ask you to go ahead and use the database settings. So this I'll go ahead and say, this is my Sigma MySQL DB, name of a database. And here I will go ahead and give the name, the username, password entry. Rest, try to use the size db t3.micro. That means there will be a server that is provisioned by AWS into which your database would be running. This is just to go ahead and keep the free tier eligible server. Otherwise, you can use any other server if you go ahead and change into dev and test in production. Just keep in mind, the cost is very, very high. So don't go ahead and provision the resources unnecessarily. The storage, 200 gigs of database storage or storage for your running or holding your databases. Auto scaling is already enabled for the storage. That's good. And it is asking, how about connectivity? At this moment, we will not connect it. We will keep it as it is, wherever it is. We will not use any connection. Okay. And it is asking, do you want to go ahead and provision? Since it's a database, my interest is very much on a separate security group called RDS security group. I just want to go ahead and use a separate security group for itself, because the firewalls that own the database should be different from the firewalls that you use it for your web servers, app servers. That is the reason I have provisioned a new security group. Rest, I'll just leave them as it is, because those are part of administration. So I left as it is, and then I'm provisioning the database. So database creation is going to take time, about 2 to 3 minutes for this instance to be up and running. So let's wait for a minute or two to see the progress of this database. Let's check the progress of this database. Still is to, like, I think it will take time. Okay, in the meanwhile, see, can you refrain yourself? Can you refrain yourself? Okay. Now, participants, what is that I'm going to do is now I'm going to go ahead and start looking at the possibilities that I should take into consideration to connect to this database. I want to go ahead and connect to this database. This is a Sigma MySQL database is getting provision. I want to go ahead and connect to this database. So let's go ahead and look out for the ways to connect to this database. So AWS RDS connection. I will put this command connection or connecting RDS. I would like to go ahead and connect to RDS. Okay. So participants, now it's time for us to go ahead and start connecting to our RDS instance, which is our RDS database instance. So here, if you look at the database connectivity, AWS does give you a lot of ways to connect. So in this current scenario, I will make it very simple and very clear. You can use console method. You can use CLI method, connecting to the database, the various ways to connect it. So I want to connect specifically to MySQL database because that is the one which you have provisioned. So if you look at the database connectivity, you can run a command using AWS CLI, right? Connecting from MySQL command line. That is very straightforward. I want to go ahead and use MySQL command line to connect to our database. So this is the summary of the command: MySQL-H, the endpoint that you want to connect, port, and the username and the password. That's simple it is. You'll be able to see the database connected. So let's go ahead and try connecting to this database. For that, let's get our server, which is our machine EC2 instance. So from EC2 instance, I would like to connect. First thing is connect and connect to this database. Okay, cool. Now I'm inside this instance. I'm taking privileges of this machine, and I'll just check whether MySQL is available for me to run the command. MySQL is not available. So let's quickly run this command for the installation purpose. This will go ahead and install MySQL on your machine. Now MySQL command, yes, MySQL is available. Double confirmation, you can even put version. It will go ahead and tell you what is the kind of MySQL client you have been installing on your machine. So MySQL is installed on this machine. The next step is to go ahead and get started, people, to the next process. That is, we are awaiting for the endpoint. I want to go ahead and connect to the endpoint via the endpoint to the database. So endpoint is ready, participants. Just get the note that to see the status. The status is still, it's saying backing up. So let's hardly wait. Like, we are just about a minute away for this database to be up and running, and the status should be available. Let's wait for about a minute. Cool. Now, database is available. Everything that we need is ready. We have to go ahead and use this endpoint to connect to the database. So I'm going to say MySQL. The one that you need to connect is this one. This is the endpoint that we need to connect. After the endpoint, the username. I gave the username Sigma MySQL DB, and the password. You don't need to enter the password. It'll ask you the password. So password should be encrypted, so it won't be showing you the password. So make sure that you enter it properly. And let's wait for the result. The expected result should be something like this. You should say, welcome to MySQL monitor, and MySQL command should be listed here. So let's check. It's not getting through. I can clearly see that it is not getting through. Participants, can you just visualize the context that why is that the database is not able to talk to the app server or the web server, or why is that the web server, why is that this instance is not able to talk to a database? What is preventing this database? So participants, in the current scenario, there is an EC2 instance that is trying to connect to this database MySQL, but it's not getting through. Why? What is the reason? This database connection is not happening.
I think we need to open the port security rules.
Okay, participants, the good thing is we have already seen number of times the scenario. Once again, I'm demonstrating you. Database in which you would be running, RDS, is governed by security group. Whether it is AWS, Azure, or any cloud, they will have their own security. Those security group act like firewall. They block any kind of request unless you authorize that request. So you have to go and tell to the security group that security group trust this EC2 instance and allow the EC2 instance. So this has to be dealt at the security level of your database. So now let's go ahead and clearly see it's confirming that, hey, I'm not able to connect to this database. EC2 instance is confirming. So let's go ahead and resolve this issue at the database level. So what to do? Go to RDS. RDS is governed by the security group. Here, the RDS security. That was another reason I wanted to keep my RDS security group very much separate. I did go ahead and provision the RDS security group here, participants. So RDS security group is now with RDS. Okay, just give me a minute, guys. Okay, so participants, now back in the session, we have the security group. We need to go ahead and fix the security group. So we need to let the security group to allow the traffic from our web servers. So how can we do? There are various ways to achieve it. The simplest way is edit the inbound group, telling the RDS security group, dear RDS security group, please allow at the port MySQL, that is 3306, go ahead and allow the web servers that we had. So the web servers we had is, you can go ahead and choose you can go ahead and choose the security group for the web servers. That's the very straightforward way. You can go ahead and allow the security groups, or you can even put the public IP address for this database. I would recommend you to use the security group. So this is the Launch Wizard 1 security group. This security group is something that you should trust and allow it. Yeah. So this is the web server security group, the security group of the web server. Please allow it. So save the rule. So after this allowance from the security group towards the web server, we need to go ahead and now rerun the command, because I want to go ahead and now double check whether this connection is getting through. With that, I'm able to get to see participants now. I'm able to go ahead and connect to this database. Everyone, are we good, participants? Hello? Participants, are we good? Now you are able to connect this database. From here onwards, database creation of the database, connecting to the database, writing the queries, the database engineer, he will take care. So are we good, everyone, on this SQL queries? Are we good with regards to the SQL queries? Participants, any questions on this part? Participants, do you have any more questions on this RDS? Okay, fine. So if you are able to go ahead and see the RDS connectivity, now let's go ahead and focus on the NoSQL databases. Now we have still now seen SQL databases. Now I want to go ahead and see NoSQL databases involving DynamoDB. So participants, database, that is DynamoDB, is a NoSQL database service offering from AWS Cloud. I hope most of you are now aware of what is NoSQL databases. NoSQL databases speaks about storing the data the way it is received in its raw format, or the way it is received, adhering to document kind of databases, document databases, key value databases. So at this moment, let's go ahead and explore what can I do with Amazon DynamoDB. So as you're aware, it's a NoSQL service. The way AWS brands this DynamoDB, it's a fully managed service. That means at your end, what is that you have to do? Zero, nothing. You don't need to go ahead and create a server. You don't need to go ahead and install DynamoDB. You don't need to provision any kind of database. No scaling, nothing. Everything is taken care. You just connect to your DynamoDB, or you start using DynamoDB. In that DynamoDB, create your database. That's all you have to do. In the backend, AWS will take care the server provisioning for you, database, storage, everything. So what will happen? We'll start receiving. You will start storing your data the way it is received without any schema design upfront, like Cosmos DB in Azure. So let's go ahead and hit our table creation. In this process, I will go ahead and create a table called employee. I would like to go ahead and create a table called employee. And the ID I would like to go ahead and keep is employee ID, EMP ID, for example, employee ID. I would like to keep it as a number. So every document in which your employee data would be getting stored will be associated with the employee ID. That means a document ID will be created. Parallel mapping. Participants, everyone, are we good? So this is the name of the database, so the table in which I'll go ahead and store the data accordingly to the employee ID. That means the data gets stored in the form of documents. That's it, guys. This is what you will be going ahead and mentioning all these details and create a table. That simple it is to create a DynamoDB table in AWS Cloud. So this table is now capable of storing any amount of data at any scale, and whatever you go ahead and store it, you'll be able to receive it. You'll be able to, whatever that a table starts to receive, it will be able to store in the form of documents. Let me show you an example. Let me take you into the employee table and let me explore the items into it. Explore in the sense I want to go ahead and add items in. Right now, clearly there are no items that are available. Item can be a document or a key value pair. So currently it is the document that I'm going to be creating. So create an item. You can use the document JSON view, the document. So let's first add in the form of a, let's keep employee ID. And let's go ahead and add a string, which is name or the first name of the employee, or let's put it in this way, name, first name, Peter, and the last name. Okay, now name is added. Let's go ahead and put up a string. His department is part of department which is purely into IT, and he's part of engineering department. And what is his designation? He is a IT consultant. Create an item. With this item to get created, now you guys can see here a JSON view for it. See, a document in which this data is getting stored. Everyone, are you with me, people? Hello? Participants, are you with me? Now you can see there is an employee document. Participants, are we good at this moment? And one thing you should have noticed, and you should have asked me about this. Kumar, did you define these values upfront? Department, designation, name, employee ID. Did I define all these, participants anytime before the table creation? Think for a minute. Did I define these values? The answer is clearly no, participants. I did not define anywhere any ID, any name, any designation upfront. It's just at the dynamic, the way the document receives the data, it stores its data. That's it. No constraints about the schema design. It's completely schemaless. There is no schema that is involved. Participants, are we good now? Hello? Participants, are we good?
Yes, Kumar.
Okay. Now, after this, once it is done, now let's go ahead and focus on writing database into DynamoDB. That means, see, the idea is, for the purpose of demonstration, I showed you manually just going ahead and writing this data into the DynamoDB. Now, I want you to think that I go ahead and create a database document for you. I'm going to go through your document for you. And let me go ahead and pick a new file. It's just a JSON file. In this JSON file, I'll go ahead and create an employee ID. The employee ID participants 100, right? So let's keep, now it is 101. It's a number. So let's keep it 101. And let's go ahead and give name of the employee. And let's go ahead and keep name is done. His department. Part of IT and part of computer science department. Next, this designation. He's a senior IT consultant. Now, extra information, his salary. Some 30,000, some random number. And what more I can add? His interests, that what kind of interest he has. Interest in driving and reading. Okay, so this is a document. So I'm going to go ahead and save this document, save as. Just going to go ahead and give a name. This document, data.json file. It's a JSON file. So JSON file is done. The JSON file is ready, participants. Now what my aim is, I want to get this file into database. Everyone, are you with me, people? Hello? Are you able to relate now? This database,
Yes.
I want to get into my employee table. Now, participants, help me with your understanding, with your best of understanding. If I go ahead and use an EC2 instance in this process, what will happen? I will go ahead and do a file upload into EC2. That means the EC2 will go ahead and do, like, just visualize a kind of a DynamoDB database is available here, which is employee database. It's an employee database. So I want to store this document now. This is item number 2, which is 2101 ID. 100 we have already covered. 100 document ID is already covered. Employee ID. Now what I want to do is I want to go ahead and use a EC2 instance to do this file upload. Now imagine, participants, if I go ahead and do this EC2 instance file upload, the file upload will go ahead and write data into DynamoDB. That is very straightforward. But what will happen if there is no files to do after that? Or what is the nature of this instance? This instance will become idle. Am I right, participants? After the files are uploaded and done, what is a nature of that instance, the nature of this instance is idle. It's completely idle. It's done. Nothing. There's nothing for it to do. So the question is now, instead of thinking this way, why should I go ahead and waste time for EC2, which is just going to be idle? Can't I go ahead and use a function? Can I go ahead and use a function that can do a file upload for me? Everyone are able to relate now? Instead of using an EC2 instance and wasting its time, can't I go ahead and use a function that will go ahead and understand that there is a file upload that is happening? Because of the file upload, it can go ahead and write into database called employee DB. Is that fine for all of you participants? Hello? Participants, are we good? Participants, are we good? Now, instead of using simple EC2 instance, I will replace this EC2 instance with a function in AWS that will do the job of file upload into DynamoDB. And participants, the functions that you will find in AWS cloud, we call it as Lambda functions, which are purely serverless. So if you go ahead and look at compute, you will find the Lambda functions, which are running your code without thinking about the servers, which are purely serverless solutions or functions in Azure, in AWS called Lambda. So now it's time for us to go ahead and start considering the
Lambda functions.
Lambda functions. Lambda is now the solution that I'm going to be using, where Lambda is expected to go ahead and pull the data from this document and write this data into DynamoDB. Participants, are we good? Everyone? Everyone, are we good? So what I'm going to do now is I'm going to go ahead and write a Lambda function. And I'm going to go ahead and create a function. So participants, since it's a function that I'm creating, so as you're already aware, it will ask you what is a programming language would you like to use? I would like to use Python as a programming language. And at this moment, I will go ahead and say file upload to DynamoDB. So DynamoDB is a service to which I will do a file upload using Python. So it will ask you to go ahead and associate permissions. What kind of permissions? Permissions means Lambda should have a right function, or Lambda should have a permission to write the data into DynamoDB table. So it is a kind of permission. Lambda should be able to read the data. So at this moment, what I will do is I will go ahead and create my own Lambda permissions for Lambda, or own role for Lambda. I will create here. I will go ahead and create a Lambda here. So let me just go ahead and look for the Lambda use case. At this moment, let's make it a little easier by giving it admin privileges, not required, but just for the purpose of practice, you can just give Lambda admin privileges. If not, you can only give DynamoDB permissions. So let's go ahead and say admin Lambda. This is a role. That's simple it is to create. This role should be now available inside the Lambda console. So just hover your mouse and check whether the Lambda is available. Yes, the Lambda role is available. And create a function. That's simple it is to create a function part. Okay. So now participants, file upload to DynamoDB, Lambda is created, which is a serverless function. And what is that? It should have the code. the code I should be writing the code, which is a Lambda code. So participants, what I'm going to do now is I'm going to go ahead and tell you what is the trigger for this function. So we have seen trigger functions in Azure as HTTP events. Now in this scenario, I'm going to be using Lambda functions, which is Azure AWS functions in the form of Lambda, to get triggered by what? As soon as this document gets uploaded. So for this purpose, let's go ahead and use S3 bucket, people. For the file upload, that means I'll put this file in S3 bucket. As soon as the file gets uploaded into S3, any of your bucket is fine. As soon as the bucket gets uploaded, as soon as that object, the right word is object, the file gets uploaded, I want the Lambda to trigger. So I'll keep the folder as data. Inside the data folder, there should be a file called JSON. As soon as the JSON file gets uploaded, this file gets uploaded, data.json or JSON file only extension is JSON file. We should be only uploading JSON file, .json file suffix. So I acknowledge it that I'm going to be using this Lambda function. So with that, participants, what I'm expecting, as soon as the folder for the S3 bucket, so in that Sigma bucket, I should have a folder called data. This is the bucket that I'm using where I will do the file upload. Clearly, I don't have any folder. So let me go ahead and create a folder called data. In that folder, I'll do a file upload of JSON, the JSON file. So what I want JSON file upload to be done into S3 bucket. As soon as the file upload is done, I want a Lambda function to get triggered. And I want to see whether it is uploading the file successfully. What I'll do, participants, is that I will put a very simple line in Python saying, hey, can you print me that event, please? Because I want to see what is going to happen. So the code I have added, participants, I'll deploy this code. And I would like to go ahead and test this now. What is the test that I want to do? I want to do a file upload. Upload, add a file, and the data.json file that I'll upload this and upload this. The moment I go ahead and do an upload, what I'm expecting, Lambda should be getting triggered. The Lambda is expected. And once the Lambda getting triggered, I should be getting output. But where I can see the output, this is not a console, or it's not an instance where I can see the output. So participants, where should I go ahead and watch the data here? What is happening inside the system? CloudWatch. Monitor, CloudWatch. I want to see the logs. CloudWatch logs. So hit your logs. You'll be able to see, or directly click CloudWatch logs. It will take you into the CloudWatch logs. It will tell you what is that event that made this Lambda to get triggered. It will tell you. So now, participants, we should be able to see the logs. The Lambda has written the logs into a log group. Event is not mentioned properly. Event is not defined in the traceback. So I think the code, I have made any mistake. Oh, cool. Here it should be. I didn't notice that. It's event context is passed here. So it should be in this line. It's pardon my mistake. I didn't notice that because this function, definition of the function is made here and I've written out of the function. So it's print. So event will be printed here. Do one more time the file upload. Upload, add the file, data.json file. I'm uploading it. Now, the moment that uploads, Lambda will get a trigger. Lambda is expected to get a trigger. Now I should be able to see a new stream from the CloudWatch. Yes, it is able to print the data. See here, it is able to print this data. Let's view this on a JSON viewer. JSON viewer. I want to see the data in the JSON viewer. You should be able to see the data format. Inside the record, there's an S3 bucket. Yeah, this is the bucket, sigma hyphen bucket, and into this, there's an object, data.json file. So that is the file from where the data is copied. Are we good, everyone? Now we are able to get two things. What are those two things? We are able to get the bucket information. We are able to get the object information with regards to key. So what I will do, I will go ahead and turn this file, the data.json file, from this bucket into Python dictionary. Using the Python code, I will turn this into a dictionary. So whatever the code that is there, it's part of a dictionary. That dictionary is written into DynamoDB. I will go ahead and write the data into DynamoDB. So what is the advantage here? The advantage is very, very simple. If there is a file upload, only then Python code will execute and it will write to database. If there is no file upload, no Python code, no data writing into DynamoDB. Point. That is the greatest advantage. In this process, no EC2 instance, so no extra cost for me. Everyone, are you with me, people? Hello, participants, are you with me, people? Hello. Participants, everyone, are you with me, people? Hello. Shall I go ahead and implement the Python code for you?
Yes, Kumar.
Okay.
Yes, Kumar.
Participants, I will go ahead and give you the Python code. I have written this Python code upfront just to save time. So I have already the Python code. I'll share this Python code after this deployment is done. Where is this Python code? DynamoDB. Give me 1 second. I kept it here, py5. Very simple Python code, the same bucket, file, dictionary, right into database. Give me 1 second. What I'm going to do now, participants, is that I'm going to go ahead and use the Python formatter. This is a little bit of Python, so don't worry if you're not understanding this. The purpose, I will tell you the summary of this, what do you call it as? The summary of this database or the summary of this Python code is, it will connect to a database called employees, read the data from your bucket and the file, turn into an object that will be turned into a dictionary. It will be writing the data into the table. What is a table? Employee table. This is the code, participants, I have written for you. And let me go ahead and put this code. JSON table and deploy the change. So it is employees. So let me confirm whether the name of the DynamoDB table is employee or employees. So let's double check the DynamoDB table. I think I kept it as employee. Employee tables. Yeah, employee. The name of the table is employee. I'll go ahead and deploy the changes now. Now, participants, get ready. The very much awaited database involving the S3 bucket. So let's go ahead and do a file upload into S3 bucket. So I have that S3 bucket ready. So I have this S3 bucket ready. 1, 2, 3. Let's go to the data folder. If you want, I would like to go ahead and delete it. delete, and I'll do a file upload now. So participants, clearly in the table, there is no database entry with the item entry for 200 or 101. There's only 100. There is no 101. So 101 entry is not available. So let's do a file upload now. Upload, add the file, data.json. So the file data.json is uploaded into S3 bucket. This file upload is the trigger for your Lambda function. Lambda will get fired up. As we're part of the Lambda function getting fired up, the Lambda will go ahead and read your bucket, read your data, read your file, turn into a dictionary, and that dictionary is written into table. What table here is employee. So it should be writing the data into table. Let's go ahead and confirm. Cool. And you go, participants. 101 entry is added. Document is added. That was really a very nice way of writing the data. This is a real-time scenario. This has been a real-time project that I have delivered. So from that experience, I'm telling you, this is a real-life scenario. Organizations use Lambda functions to write the data into DynamoDB table. So can I have a quick round of confirmation from all of you participants? Hello, participants, are we good, everyone?
Yeah.
So participants, can I have a quick round of confirmation from all of you? Okay, so what we have learned for today, we have learned the databases into AWS cloud involving SQL databases and NoSQL database. SQL databases we have connected via RDS and provision RDS instance involving MySQL and connected to that database using EC2 instance. Whereas NoSQL databases, we have provisioned a NoSQL database DynamoDB instance into AWS cloud, and we have used the proper and the right way of writing the database in the form of documents into DynamoDB using Lambda functions. So at this moment, are we good, everyone?